Okay, so we are going to talk about linear equation of order 1. An equation that is linear and of order 1 and the dependent variable y must be of the form a of x dy over dx plus b of x times y equal to c of x. By dividing each member of the equation by a of x, we obtain, for the first term, we have, so this term divided by a of x will give us dy over dx plus the second term will be b of x times y divided by a of x. So this ratio b of x over a of x can be represented by p of x times y equal to the right side of the equation will be c of x over a of x, which is a pure function of x, or we can represent that by q of x. So this is now what we call the standard form of the linear equation or linear differential equation of order 1. So the first term is basically the derivative of the dependent variable y. So it's dy over dx plus a function of x noted by p of x times the dependent variable y equal to q as a function of x, a pure function of x. Again, this is the standard form of the linear equation of order 1. For the moment, suppose that there exists for equation a positive integrating factor, okay, represented by v of x. So this is an integrating factor. So we are after to making this equation an exact equation. This equation here, wherein the standard form is multiplied by this factor, makes this equation an exact equation. But this equation is easily put into the form m dx plus n dy equal to 0. Okay, if we rearrange this, we have, okay, first distribute this v of x to this part of the equation. So we have v of x times dy, okay, and multiplying both sides by dx so that we have this type of equation. P of x times v of x, so we have this, times y times dx, so we have this, equal to the right side of the equation, which is v of x times q of x times d of x. So we have this equation now. Now arranging this into this form m dx plus n dy equal to 0 will give us this equation, wherein our m here, so we factor out, or we arranged this equation, transposing this to the left side of the equation. So this is now the resulting equation where our m is v of x times b of x minus v of x times q of x dx comes from here plus v of x dy, which is, this is our, okay, so this is our m times dx, and our n here is this one times dy. Okay. Again, take note that v, p, and q are functions of x alone. So we have isolated the value of m, which is v times p, a function of x alone times y, minus v times q, a pure function of x, and n equal to v, which is a pure function of x. Now, for us to verify that an equation is an exact, we have the test for exactness, which is the partial derivative of m with respect to y equal to the partial derivative of n with respect to x. If we can be able to satisfy this condition, then that equation is an exact. So having introduced an integrating factor will give us what really is the value of the integrating factor if we are going to do this test for exactness. Okay, so we now go to this part. We're differentiating this m with respect to y. Again, vp is a pure function of x, so you copy this. You have vp times derivative of y with respect to y is 1. So this is now our left side of the equation. And then on the right side, so we need to differentiate n with respect to x. And we know that v is a function of x alone. So differentiating v with respect to x will give us dv over dx. So we separate the variables. We have p times dx equal to dv over v. And then we integrate both sides. So we have the left side being the integral of p times dx, and on the right side is ln of v. Okay, so we are after finding for the integrating factor, the value of the integrating factor. So we interchange their positions. This integral, the integral of this part will be transferred to, or will interchange their positions. Okay, ln of v is equal to the integral of p times dx. So for us to eliminate the ln, so we need to get the anti-ln of both sides of the equation. Thus we have this v equal to e raised to the integral of p times dx. So this is now the integrating factor, or this is how we determine the integrating factor, which is e raised to the integral of p times dx. Or we can represent this by the letter I, so we will not be confused. Okay, so here are the steps in solving linear differential equation of order 1. First, put the equation into standard form. And what is the standard form? If the given equation is linear in y, so this is the standard form, where the first term is dy over dx, where the dependent variable is y and the independent variable is x. So plus p as a function of x times y. Okay, so you have this dependent variable multiplied to a function of x. And equal to, so you have the right side of the equation, q as a function of x. Again, this is the standard form of linear equation, wherein this is linear in variable y, or linear in y. Number 2, we obtain the integrating factor. So how do we obtain? We use the formula we have just derived. I is equal to e raised to the integral of p as a function of x times dx. So by arranging the given equation into standard form, you can be able to see what the value of p of x is. And the third is multiply both sides of the equation, again in standard form, by the integrating factor. Okay, and finally, solve the resultant exact equation. Means that once you have multiplied the given equation by an integrating factor, it will now become an exact equation. So you may use your known technique or known method to solve an exact equation, but there's a very useful note here that in integrating the exact equation, the integral of the left member is always the product of the dependent variable and the integrating factor used. So somehow you're able, you now have a hint on what the left side of the equation once you are solving the linear differential equation. Okay, so you have to take note of this one, that the integral of the left member is always the product of the dependent variable and the integrating factor. Okay, we now solve some examples. Let's have number 1. Solve the equation 2 times y minus 4x squared times dx plus x dy equal to 0. Now, what is the first step? We should put the equation into standard form. Okay, so observe the equation. If you can be able to arrange it into standard form, whether linear in y or linear in x, then you can now start doing it, or the next steps will be more convenient if you were able to arrange it into standard form. So this equation is actually linear in y. So dy over dx plus 2 over x times y equal to 8x. How? Basically, so we divide both sides of this equation by x to eliminate x in this part of the equation. And then here, divide dx so that we have dy over dx in the equation. So dividing both sides by x dx, we have 2y over x, okay, minus, okay, so we have this 8x, 8x squared over x dx. Cancel this. So we have 8x. So you transpose 8x into the, or minus 8x into the right side, so you have positive 8x. And the second term will be x dy over x dx, so you cancel x, giving you dy over dx here. Okay? Now you have 2y over x. So this is the term that I have just mentioned. So we have now the equation in standard form. Okay. So now let's go to the next part. So we identify that p of x is equal to 2 over x, a pure function of x. This right side of the equation is actually q of x. Okay. Now we can solve for the integrating factor, which is I equal to e raised to the integral of p of x times dx. And this is the value of p of x. So 2 over x times dx. Integrating this will give us e raised to 2 ln of x. We can simplify this by putting this function into this form, e raised to ln of x squared. So e raised to ln will give us, will cancel this function, so ln function. So this is equal to x squared. Means that our integrating factor is equal to x squared. So what's the next step? We have now the integrating factor. We then multiply this integrating factor to the standard form of the equation. So we have x squared times dy over dx. So this is the standard form of the linear equation. So we multiply, this is the integrating factor. Okay, so we now have x squared dy over dx plus, so x squared times 2 over x times y. So we have 2xy, or the x will be canceled here, equal to x squared times 8x, so you have 8x cubed. Again, this is now the result of multiplying the standard form by an integrating factor. So once we have done this, this equation will now become an exact equation. Okay, so you can now perform integration after this. Again, so as I mentioned earlier, that there's a note there that if we integrate an exact equation, so the left number is always equal to the product of, okay, so basically, so multiplying both sides by dx, so we have x squared dy plus 2xy dx equal to 8x cubed times dx. So as you can see, the right side of the equation is a pure function of x. And this is actually differentials here. So this sum here of differentials is actually can be written in this form. Okay, which is the differential of x squared y. If you differentiate this, will give us this result right here. So x squared dy You copy y and then differentiate this, you have 2x dx. Okay, so the product rule. So it simply shows that the note is really true. Now we can integrate both sides of the equation here. So if we integrate both sides of the equation, we integrate this. So we have x squared y equal to, so 8, this will become 2x raised to 4 plus c. Okay, so this is now the final answer. Okay, let's now have example number 2. Solve the equation y minus x plus xy times cotangent of x dx plus x dy equal to 0. So again, this equation is not in standard form. So we put this into standard form. So in this example, I'll be showing you how I make the equation into, how I put the equation into standard form. So copy first the equation and divide both sides by, okay, so I'm assuming here that this is linear in y. Okay, it means that I will divide both sides by dx, so I will have dy over dx. And to remove this x, I'll divide both sides by x. That's why we have this equation here, dividing it by x dx. So I'll now have y over x, negative x over x. So negative 1, xy cotangent of x dx divided by x dx will give me y cotangent of x. And then x dy over x dx will be dy over dx equal to 0. Okay, so now I'm going to arrange now. So I'll not transpose negative 1 to the right side, okay, to represent a function of x. And this here, so you have y over x plus y cotangent of x. As you can see, so y is common, so you factor out y. You have 1 over x plus cotangent of x plus dy over dx. So this is now in standard form, or to let's arrange this equation here. The first term is the derivative of the dependent variable, which is y over dx. So dy over dx plus, okay, so this is now our equation, linear equation in standard form. Okay, so we can see here that p of x is 1 over x plus cotangent of x. Of course, the right side is q of x. Now, the next step is, now that we have put the equation into standard form, we will now determine the integrating factor. Okay, so integrating factor is equal to e raised to the integral of p of x times dx. So, of course, by putting the equation into standard form, we can easily see the value of p of x, so that we can be able to solve the integrating factor. So we have this. Okay, the integral of 1 over x plus cotangent of x dx. So the integral of 1 over x times dx is ln of x. The integral of cotangent of x times dx is ln of sine of x. We can simplify this. We can put this into one term. So it's ln of x plus ln of sine of x is equal to ln of the product of x times sine of x. And e raised to ln will give me this function, x times sine of x. Now we have an integrating factor equal to x times sine of x. The next step will be to multiply the standard form of the equation by this integrating factor, x sine of x. Okay, so this is the standard form of the given equation, the linear in y. And our integrating factor is x times sine of x. We now multiply this standard form by this integrating factor. Okay, so now we have the first term. So integrating factor times dy over dx, integrating factor times this part of the equation, and then equal to x sine of x. So 1 times this is x sine of x. Now, once we have multiplied, the equation becomes exact equation. Again, so this is now an exact equation. Now you multiply both sides by dx, so we can easily do the integration. So sine x sine of x dy plus here you have x sine of x times 1 over x will give me or will give us sine of x. X will be canceled. So this factor times cosine of x sine of x. Okay, so what happened here? Cotangent of x is equal to cosine of x over sine of x. Okay, that's the identity or equivalent of cotangent of x. So we can now cancel sine of x here, giving us x cosine of x, of course, times dx. Oh, we forgot y here. So we should put y. There you go. So we've forgotten y. So then we have the next step. Okay, so we can see that this result here is actually the differential of x times y sine of x. Okay, so how is that? Meaning, if you differentiate x, y sine of x will give us this result, this part of the equation. And the right side will be x sine of x dx. Okay, now we can integrate both sides of the equation. So we integrate this. Okay, so we have now here integral of x, the integral of the left member of the equation, d differential of xy sine of x equal to the integral of the right side of the equation, x sine of x. So this can be solved using integration by parts, where our u is equal to x and our dv is equal to sine of x dx. Differentiating u will give us du equal to dx, and integrating this for us to be able to get v. So yeah, v is equal to integral of sine of x dx is equal to negative cosine of x. Now, recalling the formula for integration by parts, we have integral of u dv is equal to u times v minus integral of v times du. So plugging in to the formula, these values we have. Okay, so integrate the left member of the equation. So we have xy sine of x equal to the result of the integration by parts, which is u times v. So you have x times negative cosine of x will give us this part of the equation. And then minus integral of v, which is negative cosine of x, du is equal to dx. So you can now integrate, giving us, you copy the left member of the equation. So you copy the first term of the right side of the equation, and negative times negative is equal to positive. Integral of cosine of x dx is equal to sine of x. And then you add the constant of integration. And this is now our final answer. Okay. So that's it.